Hi, this is Max Sample, and I'm going to be explaining number 10 of the Chapter 7 homework. So, the problem says that the tub of a washer goes into its spin-dry cycle, starting from rest and reaching an angular speed of 5 revolutions per second in 8 seconds. So here I drew a circle, excuse the lopsidedness. Velocity initial is 0 radians per second. Final for this part of it, I drew 2 circles. This is the first part, we'll say, and this is the second part. Anyway, so the final for this is 5 revolutions per second because that's what it reaches in 8 seconds. And so that's in revolutions per second, but we're going to put that in radians per second, which is 10 pi radians per second. And I'm just leaving it in terms of pi to make the calculations easier right now, but I will convert it later on in the problem. Well, not convert it, I'll just multiply the pi through to the 10. So we know that time equals 8 seconds here, and so we're going to find the acceleration. And so using this rotational kinematic, we get that the acceleration is 3.93 radians per second squared. The second part says that at this point, the person doing the laundry opens the lid and a safety switch turns off the washer. The tub slows to rest in 12 seconds. So if it slows to rest, then the velocity final is 0 radians per second. And then we know from this part that the initial is 10 pi radians per second. Once again, we're going to want to find the acceleration. We use the rotational kinematic. Since it's slowing down, the acceleration is going to be the angular acceleration and the angular velocity. Sorry, I'm just going to be using the words velocity and acceleration just to make it easier. It's going to be negative since we're slowing down, so it's negative 2.62 radians per second squared. And then the question asks, through how many revolutions does the tub turn during the entire 20-second interval? Assume constant angular acceleration while it is starting and stopping. So we've already found the acceleration. And it wants how many revolutions. So in order to do that, we're going to find the angular displacement, the total angular displacement. So we're going to find it for number 1, which is our first circle. This becomes 0. Sorry, I forgot to write that. This becomes 0, as you can see right there. And then we solve for it, and we get 125.8 radians is the first one. We solve for this one. We get that it's 188.4 radians. And we find the angular displacement total. So we just add it up. We get 314.2 radians. We have to convert it into revolutions because it asks for revolutions. So just divide by 2 pi radians. And you get a final answer of 50 revolutions. Thank you.